Hey there, my name is Tim, and I'm part of the outside sales team here at Gregg Distributors. On today's Gear Up with Gregg's, we're going to teach you all about the magic of simple machines and how shivs, or pulleys, can make your job one heck of a lot easier. Have you ever seen a flag being raised on a flagpole? What about a crane on a construction site? Despite the obvious weight differences between a flag and a large load of steel, these are both examples of a simple machine known as the pulley. A pulley, in basic terms, is a wheel with a groove which you loop a rope around. The groove is important because it helps to keep the rope in place. But why do we need to know about pulleys? Well, finding the right mix of product can help you lift a load while applying less pressure. Let's dive deeper and find out how this works. The first thing you need to know is the difference between weight and mass. Mass is the amount of stuff that something is made from or contains. Weight is the amount of force that gravity pulls on a particular mass. As we all know, the moon is way smaller than the Earth. So, by being smaller, it exerts way less gravitational pull than the Earth does. If you were to instantly appear on the moon, nothing would have changed about you, but you'd suddenly weigh less. Your mass doesn't change, but your weight does. Less gravity equals less weight. While you can't use a pulley to change something's mass, you can use it to change the force needed to lift it. The more wheels you have, i.e., the more time your rope changes direction, the more you can lift. Let's break it down into some easy math. F is your force. That is the amount of pull required to move an object. In a pulley system like this one, F is the amount of force you need to apply to the rope to move the object at the other end. W is the weight of your object, which is affected by your mechanical advantage, or MA. Mechanical advantage is a measurement of how much a simple machine changes a force. Figuring out the mechanical advantage is as simple as counting the number of rope sections that support whatever you're lifting, not counting the rope section that you're pulling. So, for our example here, we only have one rope section. We can see with our formula that one rope section won't reduce the amount of work required to lift the object, but it does help us by changing the direction of our force. Instead of pulling the load directly upward, you can use your weight, which is influenced by gravity, to pull down and lift the load. The rope runs through something called a shiv, which is part of the pulley system. It's the rotating grooved wheel inside the pulley, and it's the piece that the rope fits into. In a single shiv, one pulley system, like ours here, the mechanical advantage is 1. In a single shiv, two pulley system, the mechanical advantage is 2. Another way you can increase your mechanical advantage is by having multiple shivs in one system. For example, 2 of the 2 shiv pulleys would give you a mechanical advantage of 4. However, more shivs isn't always a good thing. As more shivs and more rope come together in a system, the more friction there is. This means that a lot of shivs might mean little to no mechanical advantage. The bigger the mechanical advantage, the less force you need, but the greater distance over which that force must be used. This is because you're adding more length to your rope in your pulley system, which means you must pull more rope to lift your object the same distance. A compound pulley system multiplies your mechanical advantage by having one simple pulley system acting on another. These systems use several sheaves together, but to increase the efficiency, they are arranged either above or below each other. One common configuration for a compound pulley system is a block and tackle. This design uses a number of pulleys sharing one fixed axle at the top. This part is known as the block. The block is connected by ropes to another set of movable pulleys at the bottom. The movable part at the bottom is called the tackle. A block and tackle can help to cut down the weight of your load substantially. Let's do the math to find out exactly how much a block and tackle system can cut down the weight of your load. Okay, so let's say you have a barrel of oil that weighs about 172 kilograms. You decide to go with a 4-pulley single sheave block and tackle setup. This means that your mechanical advantage is 4. So, 172 divided by 4 is 43 kilograms. That means that you need to apply 43 kilograms of force to the end of your line in order to move the load. No matter your need, Gregg's has got you covered. Whether you want a fixed block pulley, a fixed pulley with some sway, a pulley that can swivel on a dime, or a pulley that can be moved with ease. We've got it all. Oh, and we've got both single and double sheave pulleys to suit any system configuration. Not to mention many different types of rope, wire, and cable. So, if you have any questions or need help figuring out the best way to lift your load, please don't hesitate to contact us through social media, or you can visit our website at greggdistributors.ca. Again, I'm Tim, and thank you for keeping it Canadian.